In the previous video, we have seen how if and match statements help our programs make decisions. But sometimes we don't just want to decide, we want to repeat actions. That's where loops come in. Hello everyone, welcome to another video of the Learning Rust series. A loop is a programming construct that repeats a block of code multiple times, either a fixed number of times or until a specific condition is met or changed. Rust gives us a few different ways to create the loop construct: loop, while, and for. Let's go through them one by one. The simplest one is the loop keyword. As the name suggests, it just keeps running forever, unless you tell it to stop. Let's understand by looking at an example. We'll create a mutable count variable. Loop will keep repeating the block of code. In our case, we'll just print the count. Then increase it by 1. At this point, the loop will run indefinitely with an increased count every time. Even if we add another print statement at the end outside the loop, the execution will never reach that line. Now, if we run the program, we need to manually interrupt the execution. If we want this loop to run, say 5 times, we'll check if the count is equal to 4. Then we'll exit this loop. To exit a loop, we use the break keyword. So even though loop is infinite by default, we control it using conditions and break. We initialize the count with 0. So 0 to 4 means the loop ran 5 times. So that's the basic loop in Rust. Now there can be a situation where you want to run something as long as a condition is true. In this example, where we just saw with loop, we can say as long as the count is less than 5, we'll print the count. To do this, we use the while loop. The syntax is simple. We just write while keyword followed by the condition. Then, inside curly braces, we print the count. Let's not forget the increment of count. And we'll write a print at the end outside of loop. So we know we met with the condition and exited the while loop. Now after running, we can see the same result but with simpler logic. Note, we got rid of that if statement which we were using previously to check the condition and exit the loop. While loop does all that for us. We just need to provide the condition. So you can say a bit of less code to write for us. Now the most common loop people say is the for loop in Rust. It lets you loop over a range of values or over the items in a collection. It is less verbose, more concise, and easy to use. So the example we have been looking for the previous loops, to write the same with for, all we need is for count in 0 to 5. This is the range syntax. You may remember this from our video about string slicing. This statement means that for each value in the range, count becomes 0 in the first iteration to 4 in the last iteration. All we need now is to print it like before. Let's keep the last print outside the loop to see we have concluded the execution, just making it end for. This prints our range from 0 to 4 since end index, or you can say the upper bound, is not inclusive. To include the upper bound, we use the equal symbol before the last index. So 0 to 5 is same as writing 0 to equals 4. If we now run it, it will give us the same result. Making the upper bound 5 will increase the loop by another iteration. So you can see the basic loop gives you more control, but you have to remember to handle the count, condition, and exit criteria. In case of while, condition and exit is automatically managed. You just need to handle the counter. But for loop manages everything for you. In loop and while, since you are handling the count yourself, if you need every second value or say every fifth value, you can change this increment statement to increase as per your need. Or even you can reverse the count by initializing it with the upper bound and decrease it in every loop. But in for loop, Rust gives us some useful functions to perform these. So if you need only even numbers on this entire range, you can use the step by function and pass 2 to get the every second value. This prints all the even numbers. To reverse the sequence, we can use the ref function just before the step by function. It will print the same but in reverse. You can ask why to use this ref function before step by, why not after it? It is because range is a double-ended iterator. So we can iterate both in the forward direction normally or in the backward direction using ref. However, step by function only returns a forward traversing iterator. So using ref function after step by will cause an error because rev is basically help you traversing backwards. We have one more keyword to understand here. What if we want to skip a particular condition? Say for example, we are looping from 0 to 4 but we don't want to print 1 among all the 5 numbers. How can we achieve that? By using the keyword continue. Just before the print statement, we can check if count is equal to 1, then continue. Once this keyword is executed, the program won't run the remaining lines inside the loop after it. Rather, the execution will move to the next iteration. Now if we run the program, we can see all the numbers printed except 1. Instead of range, we can also use any iterator or collections. For example, if we have an array of numbers and we want to loop through each of them, we can write for number in numbers, print the number. It will print all the numbers one by one. We can get the iterator as well by using the iter function. In our example, it won't have any effect in the result. We can get both the index and value while iterating by using the enumerate function. It will return the index and the value, which we will unpack using the tuple unpacking and assigning. So this prints both the index and the value one by one. Rust also allows nested loop. This means we can declare a loop inside another loop. So for each iteration of the outer loop, that is from 0 to 3, the inner loop will run from 10 to 13. Let's verify that by printing I and j. You can see for outer loop where I is 0, the inner loop runs from 10 to 13. This repeats for 1, 2 and 3 in the outer loop. One of the most interesting feature for loops in Rust is that it allows you to label each loop. You can ask what is the use of it? Imagine you have a situation where whenever you encounter 12 in the inner loop, you want to move to the next iteration of outer loop. So that means number 12 and 13 of the inner loop can never be printed. We know to skip an iteration, we just check if j is equal to 12, then continue. Now if we run it, we expected 13 to never appear, since we will move to the next iteration of the outer loop, but it moved for the inner one. That's why 12 never appeared but 13 did. Can we move this check j equals 12 outside the inner loop? We can't. J doesn't exist outside the inner loop. It will throw an error. The solution to this problem is to label the outer loop and use continue with that label. By the way, this is the syntax how we label the loop. You start with a single quote, then you write the name of the label and then the colon before the for keyword. Now if we run it, you can see both 12 and 13 are not getting printed. You can also change the logic as per your need. Like if we want this to happen only in the second iteration of the outer loop, so we can write if I is equal to 1 and j equal to 12, then continue. Now we can see in the console 12 and 13 are not printed for the second iteration of the outer loop. We have almost covered everything commonly used with loops, except one last thing. The simplest loop can return a value like if and match statements in control flow. For example, we want to find the first integer whose square is more than 20. For that, we'll declare a mutable counter x. Then we declare a variable which will store the integer for which the square is above 20. Now, rather making the variable mutable and then separately calculating the integer, we can directly use the loop construct. We'll perform the increment of x by 1, then check if the square of the integer is greater than 20, return the integer. This is the syntax. We use break to stop any further calculation and then followed by the value we want to return, in this case x. Finally, we need to print the result. Now if we run the program, it prints 5. We know the square of 5 is 25, which is above 20, but the square of 4 is 16, which is below 20. So 5 is the correct result. That's how loop can return a value. But note, while loop and for loop can't do this. So these are the loops in Rust and their common uses while programming. You can become good at it only by practicing. So try them and see which of these loops are the one you are most comfortable to use. And don't forget to share in the comments. That's all for now in this video. Consider subscribing so you don't miss the next one. Goodbye for now.